Good morning, student. In this video, we'll talk about reaction mechanism from organic chemistry. सबसे पहले समझेंगे what is the meaning of reaction mechanism. कोई भी केमिकल रिएक्शन, ऑर्गेनिक रिएक्शन किस तरीके से कंप्लीट होता है, उसके सारे इंटायर स्टेप्स को हम लोग रिएक्शन मैकेनिज्म कहते हैं। जनरली ये देखा जाता है कि रिएक्टेंट मॉलिक्यूल का बॉन्ड ब्रेक होने के बाद रिएक्शन इंटरमीडिएट का फॉर्मेशन होता है, विच आर हाईली रिएक्टिव एंड वेरी शॉर्ट लिव्ड स्पीसीज, एंड दीज रिएक्शन इंटरमीडिएट readily reacts with the reagent and finally converted into product. The entire process is known as reaction mechanism. तो रिएक्शन मैकेनिज्म में सबसे पहले रिएक्टेंट मॉलिक्यूल का बॉन्ड ब्रेक होगा. द ब्रेकिंग ऑफ बॉन्ड इज नोन एज बॉन्ड फ्यूजन एंड इट इज अ स्लो स्टेप which results the formation of highly reactive species known as reaction intermediate, and these reaction intermediate readily reacts with the reagent and finally converted into product. The step is very fast. The entire process is known as reaction mechanism. Now we'll talk each and every single topic in a detailed way. So let us start with the bond fusion. What is the meaning of bond fusion? It simply means the breaking of bond of reactant molecule. रिएक्टेंट मॉलिक्यूल का बॉन्ड ब्रेक को ही हम लोग क्या कहते हैं? बॉन्ड फ्यूजन. देयर आर टू डिफरेंट वेज. द फर्स्ट वन इज होमोलिटिक बॉन्ड फ्यूजन and second one is heterolytic bond fusion. Now we'll discuss about what is the meaning of homolytic bond fusion. In such type of bond fusion, the breaking of bond takes place in such a way so that each of the bonded atom acquire one single electron. For example, in case of chlorine molecule, there is a single bond between the chlorine atom, and when we apply heat or light, the bond breaking takes place and it results the formation of highly reactive reaction intermediate, which are known as free radical, and this dot represent the electron which occupied by the bonded atom after breaking the bond of the reactant molecule. In the second example, you can see that we have taken methane molecule, and in this example, the bonded atoms are different, one of which is carbon and the other one is hydrogen. So when we apply heat or light, it results the formation of methyl free radical and hydrogen free radical. So homolytic bond fusion can be summarized as that when the breaking of bond takes place in such a way so that each of the bonded atom acquire single electron, results the formation of free radical, said to be as homolytic bond fusion. The word homo means identical and lytic means breaking, and these half arrow notation shows the migration of one electron. Now we'll talk about heterolytic bond fusion. Now we'll talk about heterolytic bond fusion. When the breaking of bond takes place in such way so that the charged ions are formed as a reaction intermediate, said to be as heterolytic bond fusion. And such type of bond fusion takes place when the electronegativity difference between the bonded atom is very high. We have taken example of methyl chloride, in which we can see that there is a bond between carbon and chlorine. Chlorine is more electronegative as compared to that of carbon, as a result of which the chlorine atom withdraw the shared pair of electron towards itself and form Cl minus and methyl carbocation. Why it is called carbocation? Because the positive charge acquired by the carbon. So this reaction intermediate is known as carbocation. So the topic is very much clear to all of you that what is the reaction mechanism and what is the bond fission and what type of bond fissions are takes place. The first one is homolytic and second one is heterolytic bond fission. And it should be remembered that during the homolytic bond fission, free radical reaction intermediates are obtained, and in case of heterolytic bond fission, charged ions like carbocation, carbon ions are obtained. Now move on to another very important topic, and that is reagent. So first of all, we'll try to understand what are reagent. Reagents are the species which are responsible for the bringing of a particular type of chemical reactions. And reagents are of two types. The first one is electrophilic reagent. The word electrophilic can be explained as electro means electron. The word electro comes from electron and filling means attracting. So electrophilic reagents are those type of reagents which having tendency to attract electron or gain electron. And so we can say that all the electron deficient species are the examples of electrophilic reagent, and it is classified into two categories. The first one is charged electrophile and second one is neutral electrophile. All the positively charged ions like R plus, RCO plus, NO2 plus, these are the examples of charged electrophile. Positive charge simply indicate electron deficiency, and neutral electrophiles are those which do not possess any charges on them, but they have tendency to attract the electron, and these are nothing but electron deficient molecule, and these electron deficient molecules are aluminum chloride, beryllium chloride, boron trifluoride, and many others. Because in case of electron deficient molecule, the central atom has less number of electrons than its octet, so they have a tendency to accept a pairs of electron and behaves like electrophilic reagent and neutral electrophiles. Move on to the another type of reagent, nucleophilic reagent. These are nucleus loving and are electron rich species. All the electron rich species are the examples of nucleophilic reagent. It is also classified into two parts. The first one is charged nucleophile and second one is neutral nucleophiles. So what are charged nucleophiles? All the negatively charged ions are the examples of charged nucleophile. And what are neutral nucleophiles? These are electron rich species but not possess any charges on them. And these are the covalent molecule in which the central atom possesses unsaid pair of electron like ammonia. In case of ammonia, there is a one unsaid pair of electron on the nitrogen atom. In case of water, oxygen contains two unsaid pair of electrons. So all these are the examples of neutral nucleophile. I hope that this short session of organic reaction mechanism, basic introduction of organic reaction mechanism is almost very easily clear to all of you, and be with us for such type of important video lectures of organic chemistry so that you can understand the concept of organic chemistry in very easy and in simple way. Thank you for watching.